The threaded flange, as depicted in this example, is similar to the slip-on flange, but the bore, highlighted here in yellow, is threaded. Its principal value is that it can be assembled without welding. This feature makes the threaded flange well suited to extreme pressure surfaces and in highly explosive applications where welding may create a hazard. Threaded flanges are not suited, however, for conditions involving temperatures or bending stresses of any significance, particularly when cyclic conditions exist, which may cause leakage through the threads. In fact, after a few cycles of expansion and contraction, the threaded flange no longer performs adequately. Sometimes a seal weld is applied around the threaded joint to reduce the possibility of leakage, as depicted in this example. So here you have the threaded flange, the pipe, and here the threaded connection, and the seal weld is applied here around the threaded joint to reduce the possibility of leakage. Keep in mind, however, this technique cannot be considered as entirely satisfactory, nor is it always possible. The socket weld flange, as seen here, is also similar to the slip-on flange. It was originally developed for use in small diameter, high-pressure piping systems. Like socket weld fittings, as we have seen in a previous video, pipe is inserted into the socket, then welded. An internal weld is often employed for added strength. Then, by grinding the internal weld smooth, turbulence and flow restriction are kept to a minimum. Finally, the single line drawing symbol for the socket weld flange is seen here. Like the reducer fitting, the reducing flange, as in this example, is used to make a reduction in the diameter of the pipe. A reducing flange is most frequently used in installations with limited space. Why is that? Well, crowded situations may necessitate the use of the reducing flange simply because it has a shorter overall length when compared to a weld neck flange and a reducer fitting configuration. Be advised, however, the flow should travel from the smaller size to the larger. If the flow were reversed, as depicted here, severe turbulence could develop. Call-outs are placed on drawings to describe the reducing flange in the same manner as those used on the reducing fitting. As you can see here, large end first, small end second. For the reducing flange, one additional note is needed. The pound rating and the flange type are included in the call-out. We will see a concrete example further ahead. For now, keep in mind the reducing flange maintains all the dimensional characteristics of the larger end size. One exception, however, is the internal bore. The internal bore is actually manufactured to match that of the smaller pipe size. The following figure shows a reducing flange connected to a vertical vessel nozzle. In this example, it is a 12-inch, 6-inch, 300-pound rating, raised face reducing slip-on flange. Notice here the use of abbreviations to keep the size of the call-out to a minimum. In this example, RFSO is for raised face slip-on flange, and red FLG is for reducing flange. Finally, reducing flanges are manufactured as weld neck, slip-on, or threaded flange types. The blind flange, as depicted in this example, serves a function similar to that of a plug or cap. It is used to terminate the end of a piping system. The following two pictures depict a piping system equipped with a blind flange. As you can see from these examples, the blind flange is basically a flange that does not have a hub or a bored center. Blind flanges have the face thickness of a flange, a matching face type, and similar bolting pattern. Blind flanges can also be used to seal a nozzle opening on a pressure vessel. Take a look at the following horizontal vessel. You can see here various blind flanges that are used to seal the nozzle openings. Now, because it is bolted, as seen here, the blind flange provides easy access to the interior of the vessel or pipe, which is unlike a cap that is welded. Finally, the next figure represents the drawing symbol for the blind flange.